All right, so we're going to review backwards in this class that I did in the first class, and I have a feeling I'm going to see the same thing. We're actually going to review the hardest thing that we had a hard time with in the last class first, then we're going to hit the thing that we had unbelievable success with second in this class, and then I'm going to explain to you something that we're going to do hopefully tomorrow, which should be a lot of fun if we can handle it. However, I have a bad feeling my class is going to miss out on that, because they don't seem like they're going to be able to handle it. And that's fine. I'll have an alternate lesson plan for tomorrow for the folks that can't handle it, and those of us that are going to be able to handle it, then we'll be able to do something fun. At least I think it will be. But again, obviously you can see here, it's important that before we do anything to a distance time graph or a speed time graph, the first thing we realize is it a speed time graph or a distance time graph? Now, we noticed when we were taking some SchoolNet tests, there's also something called a position time graph, but the position time graph is the exact same thing as a what? All 3 people awake in class today. Position and distance, same thing. Position time graph, distance time graph, the exact same thing. So just remember that when you're going through these, okay? If I'm not mistaken, there's a whole bunch of drawouts in here. Again, a few parts of the motion graphs that we need to pay attention to. The x-axis, which is where time should be every time. Now, I'm telling you right now, like, I'm going to lose my mind if they decide to put speed in the x-axis and time in the y-axis, because I will not be in a good mood. I don't have a clue what I was saying now. I'm so frustrated by what I just heard. Anyway, x-axis, y-axis. They better not mix those up on us. If they do, then I'm emailing somebody. You're either going to see speed or distance here, or position. Time should always be down here. The origin is here. That's just some key parts of the motion graph that we need to kind of remember. So, not going to do that. We'll skip to the next one. Here we go. Starting with an easy graph. I want to see how the information is placed on the graph. You might need to use graph paper on the test. Again, you know, you've seen it. I know I've printed off like 4,000 sheets of graph paper for Miss Weevil this week. So it'll be the same graph paper. That's EOG graph paper. So, here you go. Auto drawing. It should pop up with the exact same thing that I see on my board, which is this. I'm going to give you a few moments to draw that, graph it, and then we're going to talk about it. All right. I'm going to assume that we are all graphing correctly. I am going to do this with red, though, just so we can, that Mr. Bones is going to make a mistake here. So 1 is 5, 2 is 5, 3 is 5, 4 is 5, 5 is 5. Okay, so everything is 1 is 5, 2 is 5. I saw a lot of people do this. And then I saw some people actually draw the line. Now, when I see this on the graph, I look at that and say, sweet, I know that. That is a flat road. No, none of these are roads, are they? There's no uphill, downhill, no flat roads. I see that flat line, and I do remember that that means at rest. It does mean at rest on a distance time graph. You are correct, sir, but I did not do what I told you to do. The first thing you should do is to pay attention to what kind of graph this is. This is a speed time graph. On a speed time graph, if every time I look at this thing it's going 5 miles an hour, it's certainly not sitting still. It is at a constant speed. Constant speed. So again, please don't make those mistakes. That's easy to do, and hopefully nobody in here did that. Whoever did this is correct. Constant speed. Moving on to the next one. After graphing this, you're going to have 1 and 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5. So I'm going to let you guys take a look at that. I'll pause the video while we do that. All right, I'm going to graph this out real quick here. So 1 is 1, 2 is 2. I see the pattern. 3 is 3, 4 is 4, 5 is 5. And I see this. And to me, it looks like that person is going up a hill. No, again, these are not hills. I look at this and I remember this is most definitely constant speed.
No.
Again, Mr. Bullens, you're not doing what you specifically told us to do. The first thing you need to do is find out.
What type of graph is it?
It's a speed time graph. On this one, even if you like take a second and look 1 mile an hour, 2 miles an hour, 3 miles an hour, 4 miles an hour, 5 miles an hour, it's speeding up. It's accelerating. It's accelerating. ACC is fine because you know what you're talking about, and those are your notes. Everybody good so far? Not too bad. I don't think that we're really struggling too much. I'll do this next one because there's no need for us to draw all of them. All right, so 1 is 8. That's not a problem. 1 is 8. 2 is 6. 3 is 4. Oops, I didn't. Yeah, I got that. 4 is 2, and 5 is that. So we're going back to the starting point. Down a hill. No. 8 miles an hour, 6 miles an hour, 4 miles an hour. You are decelerating because this is a speed time graph. Slowing down or decelerating. They probably would use the word decelerating on a benchmark, but I could see slowing down. Or it might even say, when did the person most likely hit the brakes? And don't even say the word slow or decelerating, but you should know when you hit the brakes, you slow down. Because we saw that question before. Now, again, make sure you're determining what you're doing. So if we've just done, because there's only 3 speed time graphs that we have to worry about, right? You know that we're moving into distance time graphs. So if I take this first distance time graph, and then I'll let you guys do some, because I do want to make sure we have enough time to do the part at the end that I really need before we move in tomorrow. 1 is 5, 2 is 5, 3 is 5, 4 is 5, 5 is 5, 6 is 5. Now, I just said a minute ago that this was constant speed, but I'm going to listen to myself. This is a distance time graph. I noticed that this thing never changes its position. It never changes the distance. It's always sitting at 5. It's not moving. What's that word that or 2 words that we use to describe something? At rest. It is at rest. Not a difficult one for us to understand, I don't believe. Next one is going to be up to you. Okay, I'm going to let you plot this one and tell me what's going on, then we'll come back and review it together in just a moment. All right, so we'll do this one again, talk about some things that are wrong. So 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, and straight a line as possible. Now, I do know that that's not uphill, but I'm pretty certain I remember we just did this. That's acceleration, right? No. This is a distance time graph. Now, when you have distance and time, you can actually figure out speed, correct? Distance divided by time. 1 divided by 1 is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. 5 and 5, 6 and 6 are both 1. Every time I check the speed of this object, it's going 1 mile an hour. It's at a constant speed. That would be a constant speed. Now, when I see an object like this, and you could have 3 lines, maybe a human, a pig, and a cheetah. We've seen that question before. When I see this, what do I automatically know about this graph? You have a black line and a blue line. Who is the fastest? Yes, ma'am. The steepest line, the blue line. You don't have to stress about that, do you? And I look back at that question with the human and the cheetah and the pig, and I really do kind of have to just shake my head at some of the folks in our class. I don't understand. Even if you looked at that graph and said, I don't understand that graph at all because I didn't pay attention in class. I don't understand that graph at all because I don't understand graphs. Whatever the answer to that is, if I had like 3 answer choices between who's the fastest, a human, a pig, or a cheetah, I'm going to pick the cheetah because that makes the most sense. Now, could they put it in that one of the others was faster? Sure, they could, but the odds are they're not going to do that. So will you please, on answers that you're thinking, well, I don't know the answer to this, use some common sense. Like, we're going to take a review quiz / test here in a minute. Doesn't count as anything, and I'll talk about why. We're going to take that. There's questions on there that people keep asking me, like, I don't know the answer. And it's like, well, I know these 3 aren't the answer. Then you know the answer. But this doesn't make sense. It doesn't have to make sense to you. If you can rationalize these other 3 cannot be the answer, then that 4th one has to be the answer, even if you're thinking that doesn't make sense to me. right? If you know the three are wrong, and you're like, this is wrong because of this is wrong because of this, and this is wrong, then there's no other choice but the fourth one. So just think about that when you're taking these tests and you're going through these quizzes. Last one, the only curved line. If it's curving up, we are. If it's curving down, I mean, it's possible that you could see this. I did that in red. I should have done that in black. But if somebody is like speeding and then they curve down, that's decelerating. That's all you have to remember about that. Everybody feel good about those? Yes. All right. I'm going to pause this.